Hello, my name is Kearney, and I'm going to be doing my capstone project on black holes, their history, and their future implications. Have you ever wondered how the universe will end? As everyone figures out sooner or later in their life, the expansive realm that we live in is far bigger than any one person. The universe, to date, is estimated to be 13.8 billion years old, which is 178 million times the average human lifespan. With these numbers in mind, it can be easy to lose yourself in how small of a role you actually play in the grand scheme of things. That's why so many people have dedicated their lives to discovering the plethora of secrets that the universe holds. Before getting into the history of discovering the black hole, I believe it is best to describe what a black hole actually is and what all we have discovered to this day. A black hole, on an extremely elementary level, is a very, very small point in space that sucks stuff in. This can be described essentially as an infinitely small point that acts as a gravity well that consumes matter and emits no visible light. One of the most common questions regarding black holes is how they are created in the first place. Despite most black holes being formed after a large star collapses, that's not the only means through which black holes are created. Nevertheless, black holes are indeed often created because a star collapses. It rapidly expands after consuming all of its fuel, small gases for the most part, and subsequently implodes to an infinitely small point. This process, of course, takes millions of years to complete, due to the fact that the black hole forms after the entire star's lifespan. The alternate method of forming black holes is far more rapid. This particular method does not require a star to form. A black hole it simply forms from a multitude of gaseous clouds that combine into one. Due to the extraordinarily large amounts of gases, this causes a transfer in energy so great that it skips the entire star step of a black hole. Thus, this process completes in a significantly shorter time span and creates a much larger black hole. Of course, this does not mean that the infinitely small point consuming matter is larger, no. It means that the gravity well effect that the black hole emits is far stronger, and thus creates an area void of any matter that is far larger than a standard black hole. This void of any matter is known as the event horizon, the point of no return, if you will. Past this line, not only can matter not escape, but time itself bends. As one nears closer and closer to the black hole, time slows down significantly relative to the area outside the event horizon. It is theorized that a person trapped inside the event horizon, prior to being pulled apart by the nature of the black hole, is able to see the entire future of the universe due to how significant the time bend is. However, we do not know what happens to the matter that is consumed by the black hole. Some theorize that it becomes its own small dimension, others believe it simply ceases to exist. Nevertheless, this area of black holes remains a mystery. Of course, we would not know nearly this much about black holes if it weren't for the early efforts of astronomers in the last 2 centuries. Perhaps the first person to scratch the surface of astronomy was Galileo. His work, which included progressing and popularizing the basic telescope, supporting the sun-centered universe theory, and publishing discourses concerning 2 new sciences, paved the way for modern astronomers to work with far less scrutiny and significantly more funding. Those who followed in this path included Albert Einstein and Carl Schwarzschild, 2 astronomers who were some of the first to theorize the existence of black holes. Einstein's theory of general relativity was the first work that generally pointed in the direction of the existence of black holes. However, even Einstein himself realized that such an outlandish concept of a gravity well that consumed large amounts of matter likely could not exist in the real world. Einstein's skepticism lay in the creation of a black hole being so impossibly complex to achieve. You see, in order for a black hole to be created, a star of at least 6 solar masses, 6 times the mass of our sun, has to collapse in on itself so much so that it has to be an infinitely small point. Einstein realized that an infinitely small point would obviously be very difficult to achieve, and thus began to dismiss the possibility that black holes existed. This is where Schwarzschild's work comes into play. Schwarzschild devised an equation based on Einstein's famous E equals mc squared function, which demonstrated that a black hole would be created when the radius of the collapsed star became less than what was later dubbed the Schwarzschild radius. Finally, mathematical evidence existed that proved that black holes were at the very least able to exist in the observable universe. Following Schwarzschild's discovery, many other astronomers began to study black holes, including K.Y. Low, Bruce Barrick, and Robert Brown. These 3 astronomers were the first to actually spot a black hole and confirm its existence through mathematical evidence. A star appeared to be rotating around a fixed point in space, but this point did not emit any light whatsoever. It was determined that this unknown mass could be a black hole. This black hole was located within the galaxy Sagittarius, and the black hole itself became known as Sagittarius A. Since then, many more black holes have been discovered, which leads into theories about how the universe may end. Due to the existence of what is estimated to be 100 billion black holes in the universe, some have theorized that the universe may well end in a sort of black hole apocalypse, in which every bit of matter is consumed within these 100 billion black holes, eventually forming one gigantic black hole. Of course, this is one of many theories about how the universe may truly end, so there's no real telling how accurate it actually is. Nevertheless, the existence of 100 billion black holes is certainly cause to continue studying black holes. The fact of the matter is, despite 2 centuries having been spent studying black holes, we still know so little about them. Perhaps one day, we'll truly discover what lies on the inside of black holes, and what secrets they still hide from us. Thank you.